The seemingly peaceful universe is actually full of violence, and in this chaos, the extraordinary story of Earth begins. 4.6 billion years ago, our nascent solar system was a maelstrom of swirling dust and gas, a cosmic construction site of immense scale and raw energy. Countless tiny particles coalesced, growing into planetesimals, then protoplanets, relentlessly drawn together by gravity's irresistible destructive pull. Massive high-energy collisions ignited unimaginable heat, forging a molten world, a fiery sphere constantly reshaped by cataclysmic impacts and volcanic eruptions. This nascent Earth endured an era of intense bombardment, a violent crucible where its very foundations were laid amidst a relentless cosmic storm of impacts. From this primordial fury, a unique planet emerged, scarred yet destined to harbor life, a vibrant testament to creation born from the heart of chaos. This is the epic saga of our home, forged in fire and chaos, a world of wonder born from the universe's most violent beginnings. 4.6 billion years ago, a massive interstellar collision caused the dust and rocks around the sun to begin coalescing. Gravity pulled these fragments together, and a scorching planet appeared. Finally, a scorching planet appeared without sky, without oceans, only flames and magma. This is the original Earth. The surface was continuously bombarded by meteorites. Volcanic eruptions tore through the crust, spewing molten rock and superheated gases into a nascent, toxic atmosphere. This was the initial Earth, a realm of pure, unbridled chaos devoid of any life or breathable air. No life, no air, only chaos. Billions of years ago, a nascent Earth, still forming, faced a catastrophic event. A Mars-sized protoplanet named Theia hurtled through space on a collision course. The impact was unimaginable, tearing through Earth's crust and mantle, ejecting a colossal plume of molten rock and superheated gas into orbit. From this fiery chaos, a new celestial body began to take shape. Over millennia, the ejected debris slowly coalesced, drawn together by gravity, forming our moon. This cosmic collision nearly annihilated the newborn Earth, yet from the brink of destruction emerged an unexpected, profound gift, our moon. The moon's immense gravitational pull acted as a cosmic anchor, stabilizing Earth's axial tilt and moderating its rotation. This celestial dance was crucial, paving the way for the rhythmic ebb and flow of tides, the predictable cycle of seasons, and ultimately, the very conditions necessary for life to flourish. The moon, born from catastrophe, became Earth's silent guardian, a testament to creation from chaos. In the cosmic ballet of creation, Earth, once a molten inferno, slowly cooled, transforming its fiery surface into a rugged crust. Above this emerging world, a dense atmosphere thick with water vapor swirled, promise of the life-giving element to come. As temperatures continued to plummet, the vapor reached its critical point, condensing into countless droplets. First drops began descending. What started as a shower soon escalated into a torrential downpour, world-creating deluge pounding the barren landscape. This epic rain endured tens of thousands of years, unimaginable span sculpting the planet's face. The relentless cascade filled every crater, valley, vast depression, transforming the planet's rugged surface into burgeoning waterways. From this ceaseless ancient rain, a monumental transformation occurred, the birth of Earth's primordial ocean. A testament to water's power, this ocean became the cradle of life, silent, profound beginning for everything that followed. Billions of years ago, our planet was a vastly different place, a primordial soup shrouded in mystery and extreme conditions. Deep beneath the surface, in the crushing darkness of the abyssal plains, lay the geothermal vents, spewing forth chemical-rich fluids. It was within these dark, energetic cradles that the very first sparks of life on Earth quietly emerged, hidden from the sun's light. These were not complex creatures, but tiny, single-celled organisms, the simplest forms of existence imaginable. They possessed no eyes to see, no nerves to feel, and no organs to perform complex functions, yet they held the blueprint for all future life. These inconspicuous beings, seemingly insignificant, were destined to embark on an evolutionary journey that would profoundly shape our entire planet. Through countless generations, these early cells began to reproduce, replicating their simple structures and slowly diversifying. This fundamental process of cell division laid the groundwork for the incredible biodiversity we see today. Then, a revolutionary adaptation emerged. Certain bacteria developed the ability to harness the sun's energy. This groundbreaking process, known as photosynthesis, allowed them to convert sunlight into vital energy. As a byproduct of this energy conversion, these early photosynthetic organisms began to release a gas that would forever alter Earth's atmosphere: oxygen. Initially, this oxygen was absorbed by the oceans and rocks, but over vast stretches of time, it began to accumulate in the atmosphere. This gradual oxygenation, known as the Great Oxidation Event, was a pivotal moment, fundamentally rewriting the world's chemistry. The rise of oxygen created new opportunities for life, paving the way for more complex, multicellular organisms to evolve. From the humble beginnings in deep-sea vents to the oxygen-rich world, life's journey has been one of continuous transformation. Every breath we take, every living thing we see, owes its existence to these ancient, microscopic pioneers. Their legacy is etched into the very fabric of our planet, a testament to the power of evolution and adaptation. The cinematic origin of life reminds us of the profound connections between all living things and the incredible history of Earth. Billions of years ago, Earth was a vastly different world, shrouded in a reducing atmosphere devoid of free oxygen. Life existed, but it was dominated by anaerobic organisms, thriving in the absence of the very gas we breathe today. Then, a revolutionary change began with the emergence of cyanobacteria, also known as blue-green algae. These remarkable microorganisms evolved the ability to perform oxygenic photosynthesis, using sunlight, water, and carbon dioxide to create energy. As a byproduct of this process, oxygen was steadily released into the ancient oceans, marking the beginning of a monumental shift. Initially, this newly produced oxygen didn't accumulate in the atmosphere. Instead, it reacted with vast quantities of dissolved iron in the seawater. This chemical reaction led to the formation of massive banded iron formations, or BFs, which precipitated out of the water and settled on the seabed. These geological records, composed of alternating layers of iron oxides and silica, are powerful evidence of Earth's early oxygenation. Over millions of years, as the oceans became saturated with oxygen, it began to escape into the atmosphere. This dramatic shift, known as the Great Oxidation Event, transformed Earth's atmospheric composition, with oxygen levels rising significantly. For the anaerobic life forms that had dominated the planet, this rising oxygen was not a blessing, but a deadly poison. The increase in oxygen triggered a mass extinction event, wiping out countless species unable to adapt to the new, oxygen-rich environment. The oxidation of atmospheric gases, particularly methane, had profound climatic consequences. As methane, a potent greenhouse gas, decreased, the greenhouse effect weakened, leading to a significant drop in global temperatures. This cooling effect is believed to have triggered the Huronian glaciation, one of the longest and most severe ice ages in Earth's history. Despite the initial catastrophe, the Great Oxidation Event paved the way for the evolution of aerobic metabolism. This more efficient energy production method allowed for the development of increasingly complex life forms, including eukaryotes and eventually multicellular organisms. Evidence for this transformative period is found in geological markers like red beds, ancient soils, and isotopic analyses. The Great Oxidation Event was not a single, abrupt occurrence, but a gradual process spanning hundreds of millions of years. This monumental event fundamentally reshaped our planet, laying the essential foundation for the diverse and complex life we see today.